Welcome viewers, in this video we will see the construction of a DC machine. Subscribe the channel for more electrical videos. The soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic, construction of a DC machine. The DC machine is a device which converts electrical energy into mechanical energy or mechanical energy into electrical energy. So while converting mechanical energy into electrical energy, it is called a DC generator. While converting electrical energy into mechanical energy, called a DC motor. So the same machine can be used as either a generator or motor. So there is no difference in the construction. The same machine is used for generator as well as a motor. So that it is called a DC machine. So the construction will always deal with the DC machine. So that machine can be act as either generator or motor. So the DC machine mainly having two main parts are available. The stationary part and rotating part. The stationary part is nothing but producing the magnetic flux. The stationary part is nothing but the coils are available, windings are available, so that will produce the magnetic flux. The rotating part is nothing but a armature. There also the coils are available. So the conversion of electrical energy to mechanical energy or mechanical energy to electrical energy will be takes place in the armature. Right. So we have the detailed diagram available at the time, we can easily understand. So the mainly we have stationary part, that is the coil, it will produce the magnetic flux. Rotating part called the armature, the conversion takes place in the armature. Now we'll go to the detailed diagram. So this is the stationary part. This one is the stationary part called a yoke or frame. Here the coils are available. It's called a field windings. The stationary part, the coil what is available is called a field winding. So the center what we have is the armature, rotating part. So there also coils are available. Right. So this is the stationary part and this one rotating part. So in the stationary part we will see first the yoke or frame is available, outer cover holding all these windings and armature, the outer frame is available. See, this is the pole core. Pole core is nothing but where we are going to place the coils. Here the pole core, this one pole shoe. So this dotted line is nothing but a coils, field coils. Right. So this dotted lines, this shaded portion is the field winding. So the field winding is placed in the pole core over the pole shoe. In that the coils are winded. So here the four poles are available. These two pole is the N pole. These two are S pole. So the direction of windings are given such a way that it will produce N pole. This will produce S pole, this will produce N pole and this will produce S pole. Right. So this field windings are available in the pole core over the pole shoe. So while the excitation is given, it becomes the magnet. It's called a electromagnet. So the stationary part is the field winding. It will produce the magnetic flux when the excitation is given. The poles are alternatively, N pole and S poles are available alternatively. Right. Now center what we have is the armature. What are the parts available? This is the armature core. Armature core means the place to put the windings is called a armature core. So this dots is nothing but a armature winding. So this is a cross sectional view. Normally it is available in a cylindrical form. This armature core, this armature is available in a cylindrical form. Right. So this is a cross sectional view. So here the armature core is available, over that armature windings are placed. So this dotted line refers the armature winding, so rotating part. In order to supply the current or taking the current from the armature, what we have, the brush is available. That this is nothing but a brushes. This center portion is nothing but a commutator. This commutator is a device to supply the or take the current from the armature. Right. It is a copper coils. This lines, this small line is nothing but the insulation between each and every segment. Right. So what we have here, the brush is available. that will use to collect or supply the current. Then this is the shaft, center portion is the shaft, and this is the commutator, right? So what we have, the commutator available at the center with the brushes in order to collect the current or supply the current to the armature, right? So we have stationary part, in that coils are available. When excitation, it becomes the electromagnet. At the center, the armature conductors available, and commutator with the brushes also available, right? So what will happen if it is motor or generator? We'll see that. So if it is motor, what we are, the mechanical energy is the, motor means electrical energy is the input, mechanical energy is the output. So the electrical energy is given to this armature. So the current is flowing through this armature. So it becomes a current carrying conductor. So in a motor, the electrical energy is the input, the mechanical energy is the output. So the supply is given to this armature. So the current is flowing through the armature coil. So it becomes a current carrying coil. Then excitation is given to this field winding, either self excited or separately excited. The topic is separately available. So excitation means to make this field winding into magnet. Now the supply is given to the armature coil, so it becomes a current carrying coil, and field windings are become a magnet. So what will happen if a current carrying conductor placed in a magnetic field, it experiences a force. Experience a force means it will start rotate. So that is a motor. Electrical energy is given, current is flowing through the armature coil. So this current carrying coil placed in the magnetic field, so that it experiences a force, it will start rotate, right? So this is the magnetic field, is a current carrying coil. In case of generator, what is the input? Mechanical energy is the input. That is, we are going to rotate this armature. While rotating, it should produce the electrical energy. So the generator, mechanical energy is the input and electrical energy is the output. What is the mechanical energy? We are rotating this armature by using either another DC motor or prime mover. Prime mover means diesel generator or diesel engine or petrol engine. By using that, this armature is rotated. Now this field windings are excited. It is a magnet. It becomes a magnet. So what will happen in this generator? When a conductor cuts the magnetic field, an EMF is induced in the conductor. So this conductor is now rotating. Mechanical energy is given, rotating. This conductor is rotating in a magnetic field. Whenever the conductor cuts the magnetic field, then EMF is induced in the winding, in the coil. So that EMF is collected through the brushes. Through these brushes, the EMF, the generated voltage is collected, right? So in generator, mechanical energy is given, it start rotating. At that time, the fields are, magnetic field is available. So when a conductor cuts the magnetic field and EMF is induced, that EMF is taken from through this commutator, right? So this is the machine applicable for both motor as well as generator. Based on the input, it will act as either motor or generator, DC motor or DC generator, right? So the base, it is available at the bottom, the base is available. So it will hold the entire portion of the stationary part as well as rotating part. Now we'll go to the description of this one by one. First we will see the yoke or frame. So that is the thing, outermost part of the machine. So it will hold the entire part. So it is made up of cast iron for small machines and cast steel and silicon steel for large machines. So it's the outer cover that will hold the entire part. So it is made up of cast iron in case of small machine, or cast steel or silicon steel in case of large machine. What is the function of this yoke or frame? Act as a protecting cover for the machine. So it will hold all the all the material, all the windings, everything, and also to give the protection. It is fully covered. Poles are fixed to the yoke, so it serves as a mechanical support for the part. The poles are available. right, the winding. In order to put the winding, the poles are available. During the construction itself, they will decide the pole. Either it is a 4 pole or 6 pole or 8 pole or 16 pole. Accordingly, the construction is given. Over the pole, we can place the winding. So, it is the function is to hold the winding also. Carries magnetic flux produced by the part. So, the poles available, when the winding is given, during excitation the flux is produced. So, this yoke also carries the magnetic flux. It is part of the flux also produced by, carried by the this yoke. It is a function of this yoke or frame. Next, we will go to the pole core and pole shoe. That is nothing but a field poles. Right. The field pole consists of pole core and pole shoe. First, we will see pole core. So, the pole core may be a solid structure or made of laminations. So, this is the place to place the windings. This is called a pole core. It may be solid structure, but normally it is based on lamination. Like a thin sheets, like a notebook, that the sheets are available. Every sheet is laminated so that we can reduce the losses. So that it is given by lamination. Lamination reduces the eddy current loss. It is made up of cast iron or cast steel lamination, right. The solid structure is applicable for only few machines, but normally it is made up of the lamination. Each and every, it is a thin sheet available, n number of thin sheets are compressed together, but each sheet is laminated with the varnish, so that the eddy current loss will be reduced. So, what is the function? The field winding is wound around the pole core. So, the winding is placed in the core. Core means, pole core means, there is nothing but the place to put the windings, right. So, it will carry the field winding. Then pole shoe. The pole shoe is made up of cast iron or cast steel. What is the function of this pole shoe? Support the field winding. Spread the flux in the air gap. Due to larger cross section area, they reduce the reluctance of the magnetic path. So, it is a place to put the winding. So, it will spread the fluxes in the air gap and also reduce the reluctance of a magnetic path. Now, we will go to the next part. Pole coils are field windings. Now, we discuss pole core and pole shoe. So, these windings are placed in the pole core or pole shoe. So, it is nothing but it is a copper wire wound on a former and placed over the pole. I already discussed, pole is the place to put the windings, right. So, this copper wire is the winded and placed in the pole. The field windings are concealed in series with each other. All the field windings are connected together in opposite direction, so that it will produce N pole and S pole alternatively. It is not connected in a unique direction, unique connection. It is an opposite connection, so that the alternate poles are created. They wound in such a direction around the pole core, so that alternate N and S poles are formed, right. So, it is the connections are given such a way that it will produce N and S poles alternatively, right. So, the pole core and pole shoe we discuss. In that pole core and pole shoe, we are placing the field winding. What is the function of this field winding? When a current passes through this coil, they magnetize the pole, which produce the required magnetic flux. So, the magnetic flux is produced in the field winding. When the excitation is given, it will produce the magnetic flux, right. Then we will go to the rotating part, armature core. So far what we discuss is the stationary part. So, in the armature core, it is a cylindrical shape. I already informed, cylindrical shape. In the diagram what we seen is a cross sectional and is mounted on the shaft. It is a rotating part. So, it is mounted on the shaft. It is a cylindrical shape. It is made of circular stamping, that is lamination. It is not a single piece, it is a lamination. N number of sheets are available. Each and every sheet is laminated and compressed together. It is made up of silicon steel insulated from each other. So, each and every sheet is insulated, so that we can reduce the losses. The laminated structure reduce the eddy current loss. Eddy current loss we'll see later. So it will reduce the eddy current loss. It has slots on the outer periphery to house the armature winding. The slots called a pole. The slots will be there. Over the slot the armature winding can be placed. It is made of silicon steel to reduce hysteresis losses. Right? So in order to reduce the hysteresis losses, it is made up of silicon steel. So what is the function of this armature core? To have armature winding, to place the armature winding, to rotate the armature winding in the magnetic field, produce very low reluctance path, right? So this armature core is a place to put the armature winding and thereby rotating the armature also. Now we will go to the next topic. Now we will see the armature winding. So we discussed armature. In that armature this winding is placed. That is, it is a copper wire wound on a former and placed in the slot. So copper wire is placed in that slot so that it acts as a conductor. So in this winding there are two types available, lap winding and wave winding. There are two types are available. We will see this one by one. So in this lap winding, the number of parallel path equal to number of pole, that is A equal to P. What is number of parallel path? There are n number of poles available mean n number of parallel path will be there. 4 poles available mean 4 paths will be available. The number of brushes is required to the number of poles. Used for high current, low voltage applications. Normally used for generator of capacity more than 500 amperes. Now we will see what is this winding, how it is connected. So this is a coil. These coils are available. This is nothing but a commutator. There are n number of segments are available. So in this lap winding, the number of poles equal to number of parallel paths. So 4 poles available, 4 paths will be available. See this first coil is start from here and it is connected to the second segment. First coil starts here. S1 is starts and go with the finishing F1. It is a start and finish. S1 means start, the first starting. F is the first finishing. So it starts at the coil starts at the first slot of the commutator and finish at the second slot of the commutator. The second coil start from second slot of the commutator and then finish at the third slot of the commutator. So like that the windings are placed. So there are n number of windings are available. Number of parallel path equal to number of poles. Like that it is going, lap winding, right? So each and every coil is closed, right? Start, end, like that it will go. Start from 1, end with 2. Start with 2 and end with 3. Like that it will go. Start in one slot, finish in the second slot. Similarly, start in the second slot, finish in the third slot. Like that it will go. We have the one more winding, wave winding. So another type of winding is wave winding. Here number of parallel path equal to 2 irrespective of the number of poles. So only 2 parallel paths are available, right? Start from one point, it will complete all the poles. Number of brushes is always required is only 2. Only 2 brushes are required. Start, end, like that. Used for low current, high voltage applications. Preferred for generator of capacity less than 500 amperes. So the previous one lap winding used for more than 500 amperes. This one used for less than 500 amperes. Now we will see the connection. In wave winding, one end part of coil is allied to the beginning of end part of another coil. So in the previous method, each and every coil having starting and ending. But here, one end of the one coil is the beginning of the another coil. So the same only one path, only 2 paths available. So we start with one coil, it goes to the beginning of the next coil. Has the similar polarity like the first coil. These coils are allied in a wave form and it is called as wave winding. Like a wave it will go So that it is called a wave winding. We'll see the diagram so that you're able to understand easily. So this is the commutator segments 1, 2, 3. See here, the coil 1 start at the first segment. It will go like this. It will keep on, it is rotate, keep on, it is placed, and end with the, after some places it is end with the finishing S1. Right. So if it is n number of, if 5 poles are available, 5 times it will go and end with 1 point. So starting and ending is S1 and F1 is like a wave, it will goes. But in previous case, each and every coil is completed. Right, start and end with the next slot immediately. Start 1 means it will end with the second slot immediately. Start with the second slot means end with the third slot immediately in the previous case. But here you start here, if 6 poles are available mean 6 times it will go like a wave and finish at the another point. Right. In previous case, 1 pole is completed entirely, then only it will go to the second pole, then third pole. But here all 6 poles are completed in a one like a wave, then it will complete. Right. So that's called a wave winding. Right. I think you were able to understand. Lap winding means each and every pole is completed, then it will go to the next pole. Here all poles are covered by the coil. Right. So these are segments. Now we'll go to the next one, commutator. How this commutator collect the current or supply the current to the armature winding. A commutator converts alternating voltage into direct voltage. It is cylindrical structure. It is built of segments made of hard drawn copper. The segments are separated from each other by microstrip. Is separated by microstrip. These segments are connected to the winding. Right. So we already discussed that. See this diagram. So this is the segment. N number of segments are available. So it's made up of copper and is separated by the mica strip. So there is no connection between these two segments. Right. Segments are made up of copper separated by the microstrip. So it will use to convert alternating to direct current, and one more diagram is available. So I already told it's a cylindrical form. Right. So this is nothing but commutator segment with hard drawn copper to reduce wear and tear. So this is nothing but a copper segments. So these lines is nothing but a mica insulation. Each and every segments are insulated by the mica. There is no connection, there is no short circuit. Right. So that the coil, if suppose if 12 poles are available, mean there will be 12 segments will be available. Each and every pole is supply is given separately from the segment. Right. And also it is insulated by the mica insulation. Now we'll see what is the function of this commutator. The commutator function is collect the current from the armature winding, convert the alternating current into unidirectional current. It produces unidirectional torque in the motor. Right. So it will collect the current, also supply the current. In case of motor, it will supply the current. In case of generator, it will collect the current and also convert into unidirectional current. Right. So the commutator is the important part to collect or supply the current to the armature. Now we'll see the another next topic, brush gear. To collect the current from the commutator and give it to the load. So the brushes are available, copper brushes. Right. The brush gear consists of brushes and brush holder. Because it's rotating part, the brush is available, so it will continuously collect the current from the commutator, that is from the copper segment. So what is brush? The brush are stationary and rest on the surface of the commutator. It is made up of copper, graphite or carbon because it is continuously rotating. So wear and tear will be available. So it is made up of either copper, graphite or carbon. What is brush holder? The brush holder hold the position by means of the brushes are hold in position by means of brush holders. These brushes are held by these brush holders, right? So the commutator is the place to supply the current or take the current from the armature. That is done through these brushes. The current is taken or given by the brushes. So finally what we have, the shaft. So all rotating parts are mounted on the shaft, that is armature winding, brush, everything are mounted. So it is a rotating part. So in this video we discuss about the construction of a machine, DC machine. That is the same machine used as either generator or motor. Accordingly, what are the parts available we discussed, stationary part and this rotating part. Subscribe this channel for more videos. The material is available in the link. The link is given in the description box. The other topics of the DC machine available in the also available in the description box. Thank you. Welcome viewers. In this video we will see the principle of operation of a DC motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. So the DC motor is a device which converts electrical energy into mechanical energy. When the electrical energy is given, it will convert into mechanical energy. Mechanical energy means it is rotation. The motor will start rotate when the electrical energy is given. So what is the basic principle? When a current carrying conductor is placed in a magnetic field, it experiences a force, mechanical force, which tends to rotate the armature, where the direction is given by Fleming's left hand rule and the magnitude of force F equal to BIL Newton. Now we will see what is we need to see current carrying conductor placed in a magnetic field. We will see that what is current carrying conductor and what is the magnetic field. Then due to this it will experience a force that rotate the armature. What is meant by armature? The diagram available at that time we will see that. The direction is given by the Fleming's left hand rule and the magnitude is BIL, magnetic flux density, current and length of the conductor. These three parameters will decide the force. Now we will see Fleming's left hand rule. What is the Fleming's left hand rule? So it states that sketch out the thumb, middle finger and index finger of the left hand in such a way that they are right angle to each other. We need to stretch out the left hand, the thumb, middle and index finger so that it is right angle to each other. In this case, the middle finger indicates the direction of current. The index finger indicates the direction of magnetic field, so that the direction of force of the conductor is given by the thumb, right? So these all are perpendicular to each other. Now the diagram available so that it is easy to understand. So this is the magnetic field indicated by forefinger. The current direction, current flow indicated by middle finger. Then rotation of the motion indicated by the thumb. All are perpendicular to each other. Now we will see how the current is flowing, how the magnetic field is created, then how the motion of the conductor, what is armature, how it will rotate. We will see the detailed diagram. So the diagram is available here. In a DC motor, that is DC machine, actually it is called a DC machine. The same machine can be used for motor or generator. Here we are going to use this machine as a motor. So in that there are majorly two parts available. One is stationary part and rotating part. So this is the rotating part called a armature. It's a rotating part. These are all the electromagnet, called a field winding. This is the stationary part. Field winding is the stationary part. Armature is the rotating part. So what is the principle of operation when a current carrying conductor placed in a magnetic field? So which one is current carrying conductor, which is magnetic field? So these are all magnetic field. So the magnetic field is created by the excitation. Excitation means the DC supply is given. When the DC supply is given, it becomes the electromagnet. The excitation may be given separately or self. There are two types available. Separately excited DC motor, self excited DC motor. That is the separate topic is available. So when the excitation is given, this coil, this is a field coil, field winding, it become the electromagnet. So, this is the armature rotating bar. Here the coils are available. The input to the motor is the electrical energy. So, the electrical supply is given to this armature. So, the current is start flowing through the armature conductors, right. So, excitation is given in the stationary field, that is the field winding. So, it become electromagnet. The current is electrical energy, input to the motor, electrical energy is given to the armature. So, the current is start flowing through the armature conductors. Now, this current carrying conductor placed in the magnetic field, then it will start rotate. It will start rotate, that is given by the Fleming's left hand rule. The magnitude is BIV, right. So, this is the magnetic field, this one current carrying conductor. How this magnetic field created? By excitation. How the current is flowing? The current, the input to the motor is the electrical energy. So, when the supply is given, the current is flowing through this armature. So, this current carrying conductor placed in the magnetic field, it will experience a force. So, that when the supply is given, the armature will start rotate. So, that is given by the 3 parameters BIL, magnetic field intensity, current and length of the conductor. Now, we will see the description one by one. The field magnets are excited by the DC source and a magnetic field is produced in the stationary part. Field winding is given by the DC source. So, it become a magnetic field, it produces a magnetic field. The armature winding is connected to a DC supply, there is a input to the motor. Then the current is flowing through the conductor. So, now this become a current carrying conductor, this become a magnetic field. Now, we have current carrying conductor placed in a magnetic field, hence the conductors are experiencing a force. The windings are connected in such a way that conductor under N pole are assumed to carry the current downwards and these conductor under the S pole carry the current upwards. So, the current will be upward and downward in alternate coil, so that then only we can produce the N pole and S pole alternatively in order to go for a attraction and repulsion principle, right. So, current going downward and upward alternately, so that N pole and S poles are created. The direction of force on each conductor is given by Fleming's left hand rule. Thus, the forces collectively produce a unidirectional torque which causes a rotation of the armature, right. The force is created in each and every coil, collectively it will produce the torque, so that it will start rotate the armature. Conceptually, there is no difference between the generator and motor, I already told. Same machine can be interchangeably used as a generator or a motor, right. Motor means electrical energy is given as a input, generator means mechanical energy is given an input, electrical energy is taken as a output. So, function of commutator in a motor is the same as the generator. In generator, it is used to collect the current, here it is used to supply the current to the armature winding. By reversing current in each conductor, it passes from one pole to another, it helps to develop the continuous and unidirectional torque, right. So, it will be able to supply the current continuously to the armature winding, so that it start rotating. So, it is used to help the develop the continuous and unidirectional torque, right. So, this is the principle of operation. One important thing is we have the back EMF or counter EMF. For any force we have the opposing force, here we have back EMF. Due to back EMF only the motor is rotating. We will see what is meant by back EMF. When a armature of motor rotates, the conductor also rotates. Hence, the flux, then EMF is induced in the conductor according to the Faraday's law of electromagnetic induction. So, this is nothing but the generator principle available in the motor, right. This armature conductor cut the flux. Whenever the conductor cuts the flux, EMF is generated. That is the Faraday's law of electromagnetic induction. Here the armature conductors that will cut the magnetic flux, so that EMF is induced. Now, we will see the direction. So this is supply voltage given. Supply voltage is going downward direction, but back EMF is created in upward direction. So both are opposite to each other, right? So this is the supply voltage, this is the back EMF, so armature current. So because of both the directions are opposite, it is called as a back EMF. The direction of back EMF is given by Fleming's right hand rule, because Fleming's right hand rule is applicable for a generator. Here EMF is induced, so that it is given by Fleming's right hand rule. The direction of this EMF is in opposition to the applied voltage, that is by Lenz's law, right? Now we will see what are the advantages, why we are concentrating the back EMF. We will see this one by one. Because of its opposing direction, it is called as a back EMF or counter EMF. What is the KVL equation? EB plus IARA minus V equal to 0. Otherwise, V equal to the applied voltage equal to converted into back EMF and armature resistance drop. V equal to EB plus IARA, right? So in that generator it is actually opposite. EB equal to EG, generated voltage equal to V plus IARA. Here applied voltage equal to EB plus IARA. The voltage applied is converted into back EMF and remaining will be dropped across the armature resistance. So this is called as the voltage equation of the motor, V equal to EB plus IARA. So from this we can write EB equal to V minus IARA. So that IARA equal to V minus E, that is interchanged. So that IA equal to V minus E divided by RA. The armature current is nothing but applied voltage minus back EMF divided by RA. So from this equation, back EMF opposes the applied voltage. The applied voltage will have to overcome the opposition offered by the back EMF and force the armature current into the armature, because this back EMF opposing the applied voltage, but this applied voltage need to overcome this back EMF, so that it require more current. So it will allow the armature to flow more amount of current in the armature. So that is given because it is opposing each other, but the applied voltage will try to rotate the motor in the same speed by getting the more current through the armature. V must be large enough to balance both the voltage drop in the armature resistance as well as the back EMF. So already armature resistance drop is there. In addition, we have back EMF also there, so that the voltage will reduce, but the V must be larger. V must be overcome to these two drops. So the power required to overcome EB is EB into IA. So this back EMF into IA will give us the power required to overcome. So EB can be written as P pi N divided by 60 into Z by A. So this is nothing but the generated EMF generated in generator. So the same equation can be used for back EMF also. Or EB equal to K pi into N, because all these parameters are constant, only pi and N is variable. This number of poles, conductor, parallel path all are constant. So we can write like this. So by analyzing this equation we will come to the conclusion. So EB depends upon the speed, back EMF depends upon the speed of the motor, right? So both are proportional. If speed increases, the back EMF also will increase. If speed decreases, the back EMF also decreases. So finally what it will do, so the EB will act as a governor. So it makes the motor self-regulating, so that it draws as much current as increasing. So it is act as a governor. So EB increase means speed also increase, EB decrease means speed also decreases, right? So due to that it is act as a governor. So depends upon the load, how much current is required, that will be drawn by the motor. So other thing regulated by this EB, right? So it is act as a regulator. So it is given, it draws as much current as it is required, necessary. But which amount of current is necessary, that will be drawn by the motor, right? So this back EMF will act as a important role in the motor. It act as a regulator. is a self-regulator of a motor. So in this video we discuss about the principle of operation of a DC motor. Subscribe this channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the torque equation of a DC motor. Subscribe this channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. First we will see what is torque. Torque is the twisting or turning moment of force about an axis. So it is nothing but twisting force or turning moment. So rotation. Rotation with a force is called a torque. So it is the product of force and radius at which the force is acting. So it is a product of the radius and force. Now consider this. This is maybe a drum. Brake drum of the DC motor. So radius, this is radius Rm. So rotation N in RPS, revolution per minute. So this is the force created F. So this F into Rm is nothing but a torque. What is the force created and what is the radius? These two will give the torque equation. So that is given. Torque equal to R into F Newton meter. The unit is Newton meter. Let the force of F Newton act on pulley of the radius R meter and rotate at a speed of N RPS, revolution per minute. Then the torque is nothing but radius into force. So the torque is nothing but a twisting or turning moment of the force about its axis. So it is nothing but a product of what is the force created and what is the radius of the drum. Now we will see this work done by revolution, work done per revolution. So our aim is to find the general equation for a torque. So the work done by revolution equal to work done by force in one revolution. So that this work done by force in one revolution means force into distance travelled. What is the force and what is the distance travel? That is given by this work done by the force. The force is F, distance travel is 2 pi r, 360 degree. It is rotating 360 degree. So that it is a circumference 2 pi r. So 2 pi r F is nothing but work done per revolution. The speed is given in RPS. Speed N is given in the RPS. So revolution per second equal to N. So RPS, revolution per second. So the N is nothing but revolution per second. So that work done per second is nothing but work done per revolution into work done per second. So by multiplying these two we can get work done per second. This is work done per revolution. So the work done per second is nothing but work done per revolution is 2 pi rf, that is available here. Work revolution per second is nothing but N, speed, right? So by multiplying these two, work done by second equal to 2 pi N into T. So this R into F is nothing but torque. This R into F is nothing but torque. We already discussed. The radius and force is nothing but a torque, right? So that 2 pi N into T, 2 pi speed into torque, that is nothing but work done per second watts. So this is the output we are getting. The power developed in the motor is nothing but 2 pi Nt, right? This T is nothing but R into F. So the work done per second is nothing but a power developed, that is equal to 2 pi Nt watts. If the speed is RPM, then P equal to 2 pi Nt. If the speed is RPS, if it is RPM, revolution per minute, the power developed is nothing but 2 pi Nt divided by 60, right? If it is RPM or RPM or RPS, we need to use this formula. So based on that we can go for a derivation of a armature torque. It's called a TA. Let TA be the torque developed by the armature rotating at n RPS. So again we are taking only RPS. We are not taking the RPM. We are considering RPS. So power developed based on the derivation, power developed in armature is 2 pi n into TA watts. Just now we got this expression. The same thing, the electrical equivalent of mechanical power developed. So this is the power developed given in terms of the mechanical. In terms of electrical, it is EB into IA, back EMF into armature current. So both are equal. This is given in terms of mechanical parameter, this is given in terms of electrical parameter. So we can equate on both the equations, both are power developed. So EBIA equal to 2 pi n into TA. We'll take this is equation number 3. This is equation number 1, equation number 2, and this is equation number 3. But we know that the back EMF EB is P pi n into Z by A, the general formula. So this is the equation for generated EMF that can be used for back EMF also. Now we can substitute this EB in this equation number 3. So EB into IA equal to 2 pi nt. We substitute EB, P pi n into Z by A into IA equal to 2 pi n into T. Now n got cancelled. This n, number of speed is got cancelled. So P pi Z IA divided by A into 1 divided by 2 pi equal to TA. This 2 pi is brought in the denominator. So by rearranging that, TA equal to 1 divided by 2 pi P pi Z IA divided by A. Right. So we, by simplifying this 1 divided by 2 pi, we got 0.159. The armature torque equal to 0.159 pi Z IA into P by A. The unit is Newton meter. Now we got the expression for armature torque. In the armature torque equation, this number of conductor, number of pole, number of parallel path is always constant. Only the variable is pi into IA, the flux and armature current. These two are variable parameters. Remaining are constants, or always constant. So by considering this pi and IA, if it is series motor, mean pi is directly proportional to IA, because armature, field, everything connected in series, same current is flowing through the armature and load also. So when the armature current increases, the flux also increases. So both are proportional to each other. So pi TA equal to pi into IA, right? This pi can be replaced by IA because pi is proportional to IA. So that it is IA square. TA equal to IA square. It is square of the armature torque is proportional to square of the armature current. So when the armature current increases, the torque also increases in a parabolic manner, not a linear manner. Because of IA square, it is in a increase in parabolic manner in case of series motor. In case of shunt motor, pi is constant. This pi is constant, so the TA is only proportional to IA. When the IA increases, the torque also increases in a linear manner. This will be in a parabolic manner, IA square, but this is linear manner, right? So in series motor, torque is proportional to armature torque is proportional to IA square. In case of shunt motor, it is proportional to IA. So from the equation 3, we can go for one more derivation. EBIA equal to 2 pi n into TA. Previously we substituted the EB value. Now we will keep EB as it is. So that TA equal to EB by IA divided by 2 pi n. This EB is brought, this 2 pi n is brought in the denominator. So this n is we consider as RPS. If it is RPM, you have to divide by 60. N is divided by 60. So this n divided by 60, it will go to the numerator. 60 divided by 2 pi into EBIA divided by n. So by simplifying this 60 divided by 2 pi, we got 9.55 into EBIA divided by n Newton meter. So this is also one more expression given in terms of the back EMF. If we substitute the back EMF, the expression what we got is the previous expression. So that is in terms of the number of pole, number of conductor, armature, number of parallel path, all these things. But here EB is kept as it is. So based on the data, we can use either this equation or previous equation. 9.55 EBIA divided by n, in the unit is Newton meter. Now we will go to the armature torque. Now we discuss the armature torque. Now we will go to the shaft torque. The part of armature torque is used to supply iron and friction loss, and the remaining is available at the shaft as a useful work. the torque developed in the armature is not fully available at the shaft. Some of the torque is lost due to iron and friction loss. So the remaining will be available as a useful torque, that is called a shaft torque. So due to losses, some torque is reduced. The torque available at the shaft to do useful work is called a shaft torque, TSH. Now we will find what is the expression for TSH. So the output of the motor at shaft equal to 2 pi n into TSH. N is RPS. Again we consider RPS. But the TSH equal to output of the motor divided by 2 pi n. From this we can write this. So shaft torque equal to output of the motor divided by 2 pi n. Suppose if it is the RPM, if the speed is taken as RPM, then it is output of motor divided by 2 pi n into 60. The 60 will go to the numerator. So 60 divided by 2 pi output of motor divided by n. By simplifying this, we got 9.55 output of motor divided by n. It's a shaft torque. This one is applicable for RPM. So the difference between this TA and TSH is the lost torque, and is this due to the iron and friction loss, right? The torque developed in the armature is not fully available in the shaft, that is some of the torque is lost due to iron and friction loss. So that can be calculated by subtracting these two, that will give the iron and friction loss. In this video we discuss about the torque of the motor, the general expression for torque of the motor, followed by armature torque, then shaft torque. Subscribe the channel for more video and notifications. The soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.